Hello again. Well, as we mentioned before, the presence of the magnetic nanoparticles can improve the contrast of the images that we get through MRI, okay? But by increasing the diameter of the nanoparticles as they get larger and larger, the relaxivity related to the T2 contrast is decreasing. In this slide, you just see the application of the nanoparticles, the magnetic nanoparticles, with the AU, the gold nanoparticles on their surface, which are used for not only the MRI imaging, okay, by the use of these iron oxide nanoparticles, but also for the transmission electron microscopy, the TEM imaging techniques, because the presence of the AU nanoparticles will also be really useful to get more information through the TEM imaging to see whether the particles have been internalized by the cells or not. Well, in this slide you see an example from the literature which uses the iron oxide nanocapsules because they are porous and they can be used for the loading of drugs, okay? Two different approaches has been used here. Forget about the details. Just know that when we prepare these porous nanocapsules, we can load the drugs into them, and when they are delivered into the cancerous tissue, the drugs loaded into them can be released depending on the surface coating that we have used or another mechanisms. And if you remember, we said that the magnetic nanoparticles can improve the T2 contrast. But how about the T1 contrast agents? Okay, for the T1 contrast agents, mostly the gadolinium nanoparticles are used, but the problem is that they are not soluble in water, so they have to be coated by some polymers. Again, in this picture you see one of the examples from the literature which uses the dual imaging technique, not only the MRI but also the fluorescence. How does it work? You know, it's pretty simple. It works in a way that we have the nanoparticle, okay, the magnetic nanoparticle. This magnetic nanoparticle can improve the T2 contrast and be used for the MRI technique. And if we load the fluorescence molecules on the surface of these magnetic nanoparticles, we can also appreciate the fluorescence imaging, you know, the optical imaging within this in vivo experiment. This is again another examples of the literature that instead of iron oxide nanoparticles, the manganese oxide nanoparticles are used to improve the quality of the MR images even more. And here in this example you can see that the MNO nanoparticles can be used not only for the T2, here we have the R2, forget about the differences between these, as well as the T1 contrast agents, so it can improve the quality of the MR images for both of these techniques. And don't forget that these are the MNO nanoparticles, okay? Now I just remembered that also the iron oxide nanoparticles have been used as well, so they have been combined to improve the image qualities within both techniques. In this slide, we see the use of iron cobalt nanoparticles again for the MR imaging, but the problem with these iron cobalt is that they are toxic, they are non-degradable, and they stay in body forever. They have been functionalized by the PEG polymeric chains on their surface to prevent the opsonization, and as you see here, they have improved the quality of the MR images. For the next video, we will go through the application of the gold nanoparticles for imaging techniques.